Imagine a bus full of people driving downhill toward a concrete wall. If it's moving at 3 kilometers per hour, about 2 miles per hour, what will happen? Perhaps it will simply slow to a stop, or no one will be harmed. But suppose the speed increases to 10 kilometers per hour, and it hits the wall. In that case, some passengers may fall and suffer minor injuries. Now imagine that same bus hurling at 200 kilometers per hour, about 125 miles per hour, into the same wall. The consequences would be catastrophic. Now let's apply this to our planet. For Earth, an increase in rotational speed by even half a second is an enormous shift, far more significant than a bus full of people. What is causing this change in Earth's rotational speed? On this point, I agree with specialists who have noted that changes in the core's moment of inertia are what explain the acceleration of Earth's rotation. That is indeed the case. It is changes in the Earth's core that govern the planet's rotational speed. Why am I bringing this up now? Because you must also understand that acceleration and deceleration of Earth's rotation causes physical oscillations within the magma. The inertial speeding up and slowing down of the liquid core leads the additional heat release and increases mantle vibrations. This pulsating magma pressure transmits oscillations to the crust, intensifying its heating and structural weakening. This explains the daily fluctuations in seismic activity, brief lulls followed by renewed surges in earthquake frequency. Core instability, its oscillations, and the accumulation of energy within the crust all contribute to rising internal tension. Over time, this tension reaches a critical threshold, and then major earthquakes occur. Minor earthquakes barely relieve the system. They fail to dissipate the accumulated energy. The more frequent these cycles of seismic rise and fall become, the more energy builds up in the Earth's crust, and the greater the likelihood of catastrophic events, such as those we witnessed in Turkey and Myanmar. So remember this. Even slight changes in Earth's rotational speed trigger a chain reaction within the planet's interior, leading to energy accumulation and, ultimately, to devastating earthquakes. It is precisely for this reason that the March 28th earthquake in Myanmar occurred during a transitional phase in Earth's daily rotational speed.